Areas related to circles.
I welcome all of you to this maths lesson. In this lesson, we will discuss some more example questions or some more exercise of the topic areas of combinations of plane figures. So this is the next question. Question is like this. The area of an equilateral triangle ABC is 17,320.5 centimeter square. With each vertex of the triangle as center, a circle is drawn with a radius equal to half the length of the side of the equilateral triangle. Find the area of the shaded region. Use pi is equal to 3.14 and root 3 is equal to 1.73205. So look the picture. Okay, just pause the video and just think how we can find the area of the shaded region. Okay, so here the question is like this. An equilateral triangle is given named ABC, and taking the vertices of the triangle A, B and C as the centers, three circles are drawn such that their radii are half the length of the side of this triangle. So clearly these circles will touch at the midpoints of the sides of this triangle. Now we want to find the area of the shaded region. Like the previous question, we can answer this in different way. One method is find the area of the triangle first, that is already given. Then find the area of three sectors inside this triangle and subtract the sum of the areas of these three sectors from the area of the triangle. You will get the area of the shaded region. For a sector, here the central angle, what will be the central angle? That will be 60, right? Because we know the angles of equilateral triangles are 60 degrees each. And the radius of the sector, that can be calculated because the area of the equilateral triangle is given 17,320.5. So using the formula to find the area of equilateral triangle, doing some reverse step, we can calculate the side length of the equilateral triangle, and taking the half, we will get the radius of the sector. So it is enough to find the area of one sector, then multiply by 3, we will get the sum of the areas of these three sectors. Then subtract that area from the given area of the equilateral triangle, you will get the area of the shaded region. That's one method. But actually here we don't have to find the area of a sector, because you look here, the three sectors inside this triangle, if we connect these three sectors, if we arrange them in some way, we can form a semicircle, right? 60 degree central angle, 3 into 60 degree will become 180 degree, right? So these three sectors will form a semicircle. So to find the sum of the areas of these three sectors, it is enough to find the area of a semicircle with the same radius. I think we can do in that way. So in any method, first we need to get the radius of the circle. For that, we need to find the side of the equilateral triangle. We need to find the side length of the equilateral triangle. Then taking half, we will get the radius. So how we can find the side length of an equilateral triangle? Use the formula to find the area of the equilateral triangle and substitute the given area 17,320.5 and do the reverse step, you will get the side. We can do here, given area of triangle ABC, I simply write triangle ABC, we know ABC is an equilateral triangle. It's equal to, given value is 17,320.5. And what is the formula to find the area of an equilateral triangle? I think we had discussed this formula in some of the lesson before, in some other chapter, right? So if one side of an equilateral triangle is taken as A, so the area of this equilateral triangle will be root 3 by 4 A square, right? Root 3 by 4 A square, because, so if we draw the height, we will get a 60, 30, 90 degree angle triangle, and this base, the side opposite to 30 will be A by 2. And side opposite to 60, we want to multiply by root 3, which will be A by 2 root 3. And now the area, we can write area is equal to 1 by 2 into A, the base is A into height is A by 2 root 3. Multiplying this, we will get root 3 by 4A square, right? So you can substitute this here. Area of triangle ABC is equal to, since ABC is equilateral triangle, root 3 by 4A square will come. That is given that 17,320. So in the next step, we can move this fraction root 3 by 4 to right side. So it will become, so the 4 will come in the numerator and the root 3 will come in the denominator, right? So in the left side, it will only remain A square. So A square is equal to 17,320.5 into 4 in the numerator and divided by root 3 will come. So I think here itself we can substitute the value of root 3, 1.73205. Okay, so you may think why these much digits after the decimal points are taking. Root 3 is equal to 1.73205. Because you look here, you look here, the numerator and denominator, the numbers looks like same except the decimal point, the place of the point. So if we adjust the decimal point by multiplying with some multiples of tens, we can make same numbers in the numerator and denominator. We can cancel these numbers, right? That is why it is said use root 3 is equal to 1.73205 inside the bracket in the question. Okay, so how we can adjust the decimal point here? We want to get the same number in the denominator and numerator. So in the numerator, the decimal point comes between 0 and 5. So in the denominator also, we want to make the decimal point between 0 and 5. So that means we want to shift the decimal point 4 place to right. So to shift 4 place to right, we need to multiply by 10,000, right? So to balance the fraction, we want to multiply numerator also with the same number. So we can do here, A square is equal to 17,320.5 divided by 1.73205 into 10,000 by 10,000 into 4 we can write in the end. That is equal to, numerator we can write same, 17,320.5 into 10,000 into 4. And in the denominator, we can multiply by 10,000. So point will be shifted to 4 place to right. So we'll get to 17,320.5 in the denominator. So now you can cancel the numerator and denominator because they are same. Now in the next step, 10,000 into 4, that is 40,000, right? Okay, we got A square, we need A. So what will be A if A square is equal to 40,000? So A will be square root of 40,000, right? So how we can find square root of 40,000? It's very simple, right? We know that 20 square is equal to 2 square 4 and double number of zeros. So we'll get 400. And 200 square, how will come? 2 square is 4 and you put double number of zeros. We'll get to 40,000, right? So if 200 square is equal to 40,000, then square root of 40,000 will be 200, right? We can write here A is equal to 200. So we got the side length of the equilateral triangle. So what will be the radius of the circle? Radius of the circle is equal to half into 200 will come, right? Half into 200, that is equal to 100 centimeter. Okay, now we can find the area of the shaded region. We can write here, shaded area is equal to area of triangle ABC minus area of semicircle, right? Semicircle, these three sectors inside the triangle will form a semicircle. So subtract area of that semicircle from the area of the triangle ABC, you will get the area of the shaded region. So substitute the values. Area of triangle ABC is given 17,320.5 minus area of semicircle, that is half pi r square, half into pi into r square, r is 100. So 100 into 100 we can take. So in the next step, 17,320.5 minus, we want to substitute the value of pi 3.14, that is given in the question, into 100 into 100. So in the next step, we want to multiply the first number, we can write same 17,320.5 minus. Here to multiply this, I think better we can reduce 3.14 by 2 first. In 3.14, how many 2's? In 3, 1, 2, and 1 balance, that will make 11. In 11, 5 2's, and 1 balance, that will make 14. In 14, there are 7 2's, and point will come between 1 and 5. So in 3.14, there are 1.57 2's. And that value you can multiply by 100 so that you can remove the decimal point, right? You will get 157. Again, you multiply by the second 100. It is enough to connect it to zeros, right? So we'll get to 157 and 2 zeros. So subtract this. What will we get? I think you can do that. You will get 1620.5 centimeter square. That will be the area of the shaded region. So we have substituted the approximate value. You can write approximate. So I shall explain once again fast. So in the figure, an equilateral triangle is given, and by taking the vertices of the equilateral triangle as the centers, 3 circles are drawn with a radius half the length of the equilateral triangle. We want to find the area of the shaded region. So the method we have followed is the shaded area will be the area of the triangle minus the area of the semicircle formed by connecting these 3 sectors inside the equilateral triangle. So first of all, we want to get the radius of the circle, so that we applied the formula to find the area of the equilateral triangle √3 by 4a square, and area is given 17,320. We substituted and we got the side length of the equilateral triangle as 200. Then taking its half, we got the radius of the circle, that is 100 centimeter. Then subtracting the area of the semicircle from the area of the triangle ABC, we got the final answer, area of the shaded region. So that's all in this lesson. We discussed more problems on the topic area of combinations of plane figures. So when you answer similar questions, if you don't understand, read again and analyze the picture and make a plan and then do. So when you do the calculation, you want to simplify the steps all possible ways. In today's problem, you can note some of the methods we have followed to simplify the multiplication and division in the problem.
If you like this video, please don't forget to press the like button and also share this video to your friends. So see you next time. Bye.